Now in this lesson we're going to look at what we mean by pitch and frequency. Now we've said earlier that in order to produce a sound we require some kind of vibrating source. So for example here we have three instruments and these instruments all vibrate in some way or the other in order to produce a sound. So for example in the case of the drum it will be the drum skin that vibrates. In the case of the violin and all stringed instruments it will be the string that vibrates. That includes for example the piano or the harpsichord and the guitar. These are all stringed instruments and they all rely on a string being made to vibrate in some way or the other. And in the case of the recorder, as with all wind instruments, that's to say for example brass instruments or woodwind for example, then in this case the vibrations are produced by a vibrating column of air within the instrument itself. So we have an air column. Now the difference is produced by this air column and the string, and that for example produced by a drum, is that the string and the air column produce a much purer sound, a much higher quality sound, which we call a musical note. That's to say the string and the air column vibrate in a very regular way, whereas the drum skin is not quite so regular, so the sound doesn't really sound so good. Now the violin works by drawing the bow across the string, and the friction between the bow and the string sets up vibrations in the string. Now if we could slow down those vibrations we would see the string move like this. For example, we would see it first of all move this way, and then it would come back to the middle and then move this way and then go back to the middle again. Okay, if we could just sketch that. So the string would go up this way, back to the middle, down this way, and then back to the middle, and we would call this one cycle. Now the pitch of a note is a measure of how high or low the sound is. Okay, so if the sound has a high pitch, then it means that the source is vibrating with a high number of cycles every second, and if it has a low pitch, then the source is vibrating with a low number of cycles every second. So we can say that the pitch is a measure of the number of cycles that are produced every second. Now, in music, we talk about the pitch of a note, but in science, we use a different term. We use the word frequency, and we can say that the frequency is exactly the same as the pitch. They are different words to describe the same thing. So the frequency is the number of cycles produced by a vibrating source in 1 second. So if this violin string is vibrating with a high frequency, then it's producing a large number of cycles every second. And if it's vibrating with a low frequency, then it's producing a low number of cycles. Now, in equations, the word frequency has a symbol. The symbol capital F is normally denoted for force, so frequency has been allocated the lowercase f, right? That means frequency, and as we just said earlier, the unit for frequency is the cycle per second. And as is very often the case in science, somebody will come along and say, well, we're going to confuse everybody by inventing a new unit to represent these cycles per second, and that new unit is called the hertz. You know, I have a bee in my bonnet about this. It's just as if somebody were to come along and say, well, we're not going to use kilometers per hour anymore to measure speed, we're going to use the Hamilton after Lewis Hamilton, and all that serves to do is really, confuse things for generations and generations of students, because you lose the meaning really of what's going on when you do that. But anyway, I'm afraid you've got to stick with it. The hertz is the official unit for frequency, but we must always remember what the hertz means, and the hertz is the number of cycles that something completes every second. So 1 hertz is exactly equal to 1 cycle per second. That's what the hertz means. So if this violin string is playing middle C, then it means it's vibrating with a frequency of about 262 hertz, which means it's completing 262 cycles every second. That's to say it's going that way, back to the middle, down to the bottom, back to the middle again, 262 times in 1 second.